Hello viewers, welcome once again back to my channel, Math Made Easy with PDY. If today is your first time joining my channel, please kindly subscribe and share my videos with your friends. Let's make math very easy for people to understand. We are still on our series in terms of revising the topic bearings. So in our previous lesson, we looked at some of the objective type questions. In today's lesson, we are going to look at some of the subjective type questions. So the first question we are going to work on is the question that came in the year of DEC 2012. It was question number 8B, and it reads, P, the points P, Q, and R are three villages on a level ground. Q is 4 kilometers on a bearing of 040 degrees from P, while R is 3 kilometers on a bearing of 130 degrees from Q. Calculate the distance and bearing of P from Q, and then state vector PR in distance bearing 4. So without wasting my time, let's make a small sketch of the information. So we are told that Q is 4 kilometers on a bearing of 040 degrees from P. Therefore, let us draw our cardinal points to show the location of P leading us to Q. So that is my north to south pole, and that is my east to west pole. So I have my north here, east there, south and west there. So showing the direction 040 degrees, as you know, this is P. 040 degrees will lie in the first quadrant. So we have a terminal line leading us to Q. So let me have this as my line leading to Q. And my 040 degrees will be shown between the north pole and the terminal line. So we have the location of Q here. When you continue, so we have a distance also 4 kilometers. So we need to show that. While R is 3 kilometers on a bearing of 130 degrees from Q. So we have to draw the cardinal point at Q. That will lead us to R. So I have my cardinal point here. And therefore, reading 130 degrees from the north pole of Q, the terminal line will fall within the fourth quadrant, which is between south and east poles. Therefore, I'll have it here. But remember, we are told that the distance from Q to R is 3 kilometers. So that should be shorter than 4 kilometers. So I can assume that this is my 3 kilometers. So it can be shorter a bit. So that is the location for R. And that is the bearing of 130 degrees. So in this case, let us connect to find out some of the missing angles so that we'll know what type of triangle we are joining from P all the way to R, because the question says find the distance between PR. So we need to connect from P to R. P to R. So that is what I have here. P to R is here. Good. So if that is P to R, then let me use different angles to find the missing angles which are not there. So I'm first looking out for the remaining angle between the south pole, and then the terminal line that leads me to R. So having 130 degrees here, then it means the smaller angle here is going to be 50 degrees. You just have to subtract it from 180. 130 out of 180, you get 50 degrees. Secondly, I have 40 degrees here, and as you know, the cardinal points are parallel to each other. So when you have a connection between a transversal line and any other cardinal point, then it means that you are going to get parallel lines connection. And hence 40 degrees here, so we can say the 40 degrees here alternate also at the angle location here. So we have this section also as 40 degrees. So the total angle at the point P with respect to P, at the point Q with respect to P and R is 90 degrees. So our structure gives us a total angle of 90 degrees here at Q. And the shape looks like a right angle triangle. So finding the distance between P and R, then we can use the Pythagoras theorem. We can use the Pythagoras theorem. I forgot to bring our 3 kilometers distance. So 3 kilometers, it's here. So using Pythagoras theorem, since the 90 degrees is facing the side PR, then PR becomes our hypotenuse. So the length of PR must be equal to the square, the sum of the square of the other two sides. So we have 4 kilometers all squared, 4 kilometers all squared, plus 3 kilometers all squared. And then we find the square root of it, and that gives us an answer to PR. So that is going to be square root of 16 plus 9, and that will be square root of 25. So we are having it as 5 kilometers. So you can say that therefore the length of PR, or the distance between P and R is equal to 5 kilometers. 5 kilometers. Now, without wasting my time, then we move on to calculate the bearing of P from R. The bearing of P from R. So it means we need to stand at the point R. And this is the location of point R. That's the location of point R. So we need to draw our cardinal point at R. We need to draw a cardinal point at R. Let me use a green marker for that. So drawing a cardinal point at R, then we have it as that. Now, looking at it carefully, it means we are reading our bearing. Let me use a red marker to show the bearing. From the north pole of R in the clockwise direction all the way to meet the terminal line that leads us to the point P. So analyzing whatever we have here carefully, then it means we need to find some smaller angle. It looks so small, but we are going to work it out, so you may see it very clearly soon. Therefore, how do we determine that? There are so many ways of determining the smaller angle found here, which is just this corner. We need to find that angle. That angle alternates with the angle here. They do alternate. So we can find that angle and then add it. We subtract that angle from 270 degrees. Automatically, it will give us the bearing of P from R. How then do we find that angle? Remember, we are having 40 degrees as the bearing of Q from P. So it means we can find the remaining angle towards the east post of P. And that remaining angle will automatically be 50 degrees. And what do I mean by that? Let me use the yellow marker to show the angle I'm talking of. So the whole of this angle here to the east post of P will actually give me a total value of 50 degrees. Since between the north pole of P and the east pole of P, the total angle is 90. So if part of it is 40, then the remaining angle must be 50. So we need to look out for the angle subtended by QPR on the line QR. So we have to look out for this angle. Let me use a black marker to show. We need to look out for the total angle here. So we are finding angle QPR. So finding angle QPR, I believe we can give it an angle letter, so that can be theta. So let's try and find theta. When we get the value of theta, then we can subtract that value of theta from the total angle 50 degrees, and then that will give us a smaller angle that we are interested in. So since the whole triangle is a right angle triangle, and trying to find the angle theta, then it means we can use a trig ratio for that. Remember, using the trig ratio, we know the sides 4 kilometers and then 3 kilometers, and therefore it means we can use tan ratio. So tan of the angle theta must be equal to the opposite side of theta is 3 kilometers. So we have 3 all on 4. So finding theta will be equal to tan inverse of 3 on 4. So when we work out the tan inverse of 3 on 4, you can use your calculator to help you do that. So tan inverse of 3 on 4 gives us an answer of 36.86 degrees, which is approximately 37 degrees. So now we can find the smaller angle that we are actually interested in. That smaller angle. So probably you can just write it as small angle will be equal to our 50 degrees minus the 37 degrees we've actually obtained. So when we strike the difference, so we have 50 minus 37, and that gives us an answer of 13 degrees. So we have 13 degrees here, but that isn't the bearing. So in order to obtain the bearing of P from R, then that is going to be equal to 270 degrees minus the smaller angle we've actually worked out, which is 13 degrees. So 270 degrees minus 13 degrees gives us an answer of 257 degrees. Remember, they asked us to state the vector PR in a distance bearing form. The vector PR in a distance bearing form. So in order to get the distance bearing form of vector PR, it's so simple. The distance bearing of vector PR, we know the distance between P and R has been worked out, and that is 5 kilometers. And in order to get the bearing, we simply have to add up the angle theta that we calculated for, which was 37 degrees, to the 40 degrees. So that is going to give us 40 plus 37 degrees, and that will be 5 kilometers and then 77 degrees, which is 0.77 degrees. Now someone may ask, why did I add 40 degrees to 37 degrees to obtain 0.77 degrees for the bearing of the vector PR? We did so for the fact that, remember, we are moving from the source P towards R. So we can't use RP. It's supposed to be PR. And then in order to get the bearing from P to R, then that is a 40 degrees plus the angle theta we calculated for, and that will lead us towards what? R. That is why there was a need for us to add the 40 degrees to the angle theta, which was 37 degrees. Therefore, this is how you could have solved this question. Let's take another example. So going to another example, we have 2 points A and B on a bearing 0, 4, 0 degrees and 120 degrees respectively from the point O. If OA, the length of OA is 12 meters and the length of OB is 15 meters, calculate correct to 3 significant figures the distance between A and B. So in the same way, since we've started learning how to sketch and then get information rightly done, making a sketch of the information, we are told that 2 points A and B are on the bearing 0, 4, 0 degrees and 120 degrees respectively. So from the point O, let us show our point O. Let us show our point O. So let me have my cardinal points drawn and label the location as O. And hence, the bearing to A is 0, 4, 0 degrees, which will lie in the first quadrant. So 0, 4, 0 degrees may find itself here. But remember, the distance was 12 meters. So let me assume that that is my location for A, which is 12 meters. And then that of OB, which is 15 meters. And then on a bearing of 120 degrees, let me locate 120 degrees. 120 degrees may find itself within the fourth quadrant or between the south and east poles for O. So 120 degrees, that will be 90 plus 30. So I have an extra of 30 degrees here. But that distance, as you know, was 15 meters, longer than 12 meters. So let me have it there. And that leads me to the point B. So I have 15 meters here. But remember, the total angle is 120 degrees. So let me write it out here, 120 degrees. So that is what we have there. Then we are told to find the distance between A and B, just the distance between A and B. So we need to connect from A to B with a straight line. So we have it that way. Therefore, what type of triangle have we drawn? We actually don't know. I didn't write my 0, 4, 0 degrees, so let me put it there. So I have my 40 degrees between the North Pole and the terminal line that leads me to the point A. So 40 degrees has been shown. Therefore, what is the remaining angle? The remaining angle is going to be between the North Pole and then the East Pole. That will be 50 degrees because the total should be 90. And then I have between the East Pole and the terminal line that leads me to B, the total length was 120 degrees. So we subtract 90 from 120, we get an angle of 30 degrees. So we have 30 degrees here. So then it means that the total angle at point O leading to point A and B is 80 degrees. It's 80 degrees, the total angle. Let me use a different color to show that. So we have the total angle here as 80 degrees. So in order to find the distance of A, B, then since our shape does not give us a right angle triangle, we have no choice than to go for the services of what we call the cosine rule. Two sides are known, and then the side we are looking for, its interior angle is also known. So you can use the cosine rule to find that. Now, if you don't know much about cosine rule, I've made a video on that, so you can go back and then check in my videos the cosine rule and how it was deduced. So to quote the cosine rule for our shape here, we can say that then the length of AB all squared must be equal to the length of OA all squared plus the length of OB all squared minus 2 times the length of OA times the length of OB, then cos of the angle, and the angle is AOB. So let's do a simple substitution. The length of AB, then all squared will be equal to OA is actually 12 squared plus OB, which is 15 squared, minus 2 times 12 times 15, then cos of the angle 80 degrees. Simplifying, we have 144 plus 225 minus 2 times 15 times 12. That gives us an answer of 360 degrees. So we have 360 degrees cos of 80 degrees. AB still repeats itself. So we have 144 plus 225, 144 plus 225, an answer of 369, minus, when we simplify 360 cos 1, cos 80, 360 times cos 80, from our calculator, we obtain 62.5133, and then let's subtract 369 minus that, so we have 369 minus that gives us an answer of 306.486656. So AB squared, now AB, the length of AB will be square root of what we have here. So when we find the square root of our answer, we end up getting 17.50676, and that is AB. But remember, we are asked to leave AB, the distance between A and B, to 3 significant figures. So to 3 significant figures, we are getting AB as 17.5, and the unit is meters. That is 3SF. That is 3SF. I believe you followed the lesson carefully, and it's so simple. So cosine rule is very, very important for you to actually understand. Let's take one last example on a subjective question with respect to bearing. And with the last example, we have a cyclist moves 40 kilometers from a point P on a bearing of 0.45 degrees to Q. He then moves 20 kilometers on a bearing of 135 degrees to R. Calculate A, the distance between P and R, correct to 3 significant figures, and then the bearing of P from R. Without wasting my time, let's make a sketch of it. So making a sketch of it, we are going to have a cyclist moves 40 kilometers from a point P on a bearing of 0.45 degrees. So we first have to locate the point P. So drawing my cardinal point and stating it as point P. So that is my point P. That is my point P. Now, a bearing, the cyclist moved from this point P, 0.45 degrees. 0.45 degrees is actually northeast, so it lies perfectly here. And 40 kilometers. So 40 kilometers, it should be longer. So we have 40 kilometers shown. 40 kilometers shown. And so the cyclist moved on this terminal line to kill. So we got into kill. And then he moves 20 kilometers on a bearing of 135 degrees. So 20 kilometers on a bearing of 135, we need to draw our cardinal point at kill. So I've drawn my north to south pole. Therefore, I have my east to west pole here. So having 135 degrees, which we will find itself in the fourth quadrant, then we have it here. But that distance was very short, 20 kilometers. So it should be half of probably 40 kilometers. So let me have it there. And we label it the point R. Now, getting to point R, let us show 135 degrees from the North Pole. So we have the whole of the angle here as 135 degrees. Moving forward, calculate the distance between P and R. So as you know, you just draw a straight line to connect P to R. So that is what we have here. We connect P to R. Moving on, then in order to find the distance between P and R, we need to look out for some of the missing angles to be convinced what type of triangle we are having on board. So since from the previous information, we have 45 degrees as the bearing here. I forgot to bring it. Let me bring it back. So I had here as 45 degrees. Then it means this 45 degrees will alternate with part of the angle between the west pole and then the south pole for kill. So here is also going to be 45 degrees. And also having 135 degrees from the north pole to the terminal line, that leads me to point R. Let's subtract 135 from 180 degrees. So 135 out of 180, what do you think? So we have it as an angle of 45 degrees. So we have here as 45 degrees as well, 45 degrees. So obviously, the angle at Q connecting the points P and R is a total angle of 90 degrees. So our shape is a right angle triangle. Let me put my 20 kilometers also at QR. So having a right angle triangle and finding the distance PR, then we can say that using Pythagoras theorem, PR all squared must be equal to the sum of the square of the two sides. So you can choose to write it as PQ all squared plus QR all squared. But you could have also gone straight ahead to do your simple substitution. So that is going to be 40 squared plus 20 squared. 20 squared. And in order to get PR will be equal to the square root of 40 squared plus 20 squared. What answer do we have? That gives us a total answer of 2000. So we have 2000 here. Then we find square root of 2000. So square root of answer, that gives us 20 root 5. So PR is equal to 20 root 5 kilometers. But we are asked to leave the answer to 3 significant figures. So when we change it to decimals, we are getting 44.721 kilometers. But to 3 significant figures, that will be 44.7 kilometers. That is 3SF, 3 significant figures. So we are done finding the distance between P and R. The last part says we should find the bearing of P from R. The bearing of P from R. So we need to stand at R, draw our cardinal point. Draw our cardinal point at R. And then we have to read the bearing from the north pole of R towards the terminal line that leads us to P. So this is what we are actually going to look out for. But to make it very easy, then it means, as you know, let us come to P. There's a remaining angle at P before we get to the east post of P. Let's try and find that angle. When we get that angle, it will alternate with the small angle that leads you to the west post of R. Then you subtract that value from 270 and straight ahead it gives you the bearing of P from R. So without wasting my time, what do we do to get a small angle there? I don't have enough space. I could have called it alpha. Let me call that angle alpha, but let me write it outside here. And then there's an inner angle here at P, which connects to Q, and that connects also to R. Let me call that angle theta. So I'm trying to look for the angle theta and alpha, but I'll use alpha to help me get the bearing. So how then do we find that? Before that, remember the total angle left from the 45 degrees bearing to Q is also 45 degrees. So let me use a black marker to show that. The remaining angle from this edge to the east post is also 45 degrees. I hope you are following. So if that is 45 degrees, let me try and find the angle theta. Finding the angle theta, I know my structure is giving me a right angle triangle. Therefore, I can use a trig ratio to find the angle theta. And which angle theta, which trig ratio would be appropriate? That would be tan. So tan of theta must be equal to the opposite side, which is 20 kilometers over 40 kilometers. So theta will be equal to tan inverse of 2 on 4, which is the same as 1 on 2. So tan inverse of 2 on 4, actually tan inverse, so I'm keying it onto the calculator. Tan inverse of 2 on 4 or 1 on 2 will give me an answer of 26.565 degrees. So I have theta as 26.565 degrees, which is approximately theta is 27 degrees. So in order to get alpha, alpha will be equal to my remaining 45 degrees minus the 27 degrees I've actually calculated for. And what answer do I get? 45 minus 27, that gives us a value of 18 degrees. So alpha is 18 degrees. Therefore, the bearing of P from Q will be equal to, then we subtract the value of alpha from 270 as I said. So 270 degrees minus alpha, and that is 270 degrees minus 18 degrees. So 270 degrees minus 18 degrees gives us a value of 252 degrees. So therefore, the bearing of P from Q is 252 degrees. Thanks so much for joining the call. It's a great privilege always coming your way to make math easy for you. You can go back and watch the video once again and then give me your support by liking and sharing the videos with your friends. Have a nice day. Bye-bye.